All right, let's look at this one. Write it down and try it. First thing I'm going to look at when I'm solving a log equation is I want to make sure I have a single log. So when I look at my equation right here, I see that I have two logs. So what I want to do is condense, which means I'm going to use my log properties. So as you can tell, I have log 45x minus log 3. Since it's separated by a minus, I'm going to use the quotient property. I want to condense it to a single log. So log, this is base 10, which we don't write. My numerator is 45x, and my denominator is, the 3 is equal to 1. Once you have condensed it to a single log, then what you want to do is switch forms. So you need to remember that when you have a log and you don't see a base, that means it is a common log. Common log always has base 10. So when I want to switch forms, I'm first going to write the base. So it's 10. And my exponent is 1 right here, because the log always equals to the exponent, is equal to my value, which is all of this fraction, 45x over 3. Okay, from here you're just going to simplify. So 10 to the 1 is 10, and I rewrite everything else. You can write 10 as 10 over 1. And what we want to do when we have a proportion is cross multiply. So 45x times 1 is just 45x is equal to 3 times 10, which is 30. Here I have my little butterfly. All right, we want to solve for x. So I want to isolate my x. I'm going to divide by 45 on both sides. This will cancel. So look on the right side. I'm going to have x is equal to 30 over 45. Of course, we always want to simplify our fraction. So 30 and 45, what's a common factor is 5. 30 divided by 5 is 6. And 45 divided by 5 is 9. We could still reduce that. I can divide 6 by 3, and that will equal 2. And 9 divided by 3 is 3. So our answer is, look over here. X is equal to 2 over 3. Okay, you may be asking why I didn't reduce 45x over 3. Well, you could do that, and if you can simplify your fraction, then you should. So I can just rewrite 45x over 3 as log 15x equals to 1. I should get the same answer. Right here I'm going to switch forms again. My log again has base 10, so I will rewrite 10. Right here, this little 10, usually not written in. 10 to the 1 is equal to 15x. And this would make it a lot simpler if I did it simplified in advance. Divide by 15 on both sides. This would cancel. So 10 over 15 equals x. And then, of course, I would simplify 10 over 15, divide by 5 on both sides, and I would end up with the exact same answer, 2 over 3. All right, try this one. Log base 4 of 100 minus log base 4 of x plus 1 equals 1. Okay, so again, I always want to condense my log as much as possible. So I have 2 logs here on the left. Both have a base 4. And since they are separated by a minus, I again can use the quotient property. Squishing that in. Okay, so rewriting it, I will write it as log base 4, only a single log, right? Log base 4, just one time. In the numerator, I will have 100. In my denominator, I will have x plus 1. And that will equal to 1. Once I have it written as a single log, there's my value, I can switch forms. Remember, when I switch forms, I always want to write my base first. Here's my base. So 4 exponent 1 is equal to 100 over x plus 1. 4 to the 1 is just 4 is equal to 100 over x plus 1. I can write the 4 over 1, and now I have a proportion again, so I will cross multiply. So 4 times x plus 1, will give me 4 times x plus 1 is equal to 1 times 100. It's my little butterfly. All right, I just have a simple algebra multi-step equation, so I'm going to distribute the 4. 4x plus 4 is equal to 1 times 100 is 100. Subtracting 4 on both sides, I'm going to have 4x is equal to 96, and then 4x equals 96. Divide by 4 on both sides, so x equals 96 over 4. And of course, we want to reduce. All right, and we're going to reduce this fraction. You can see that 4 into 9 right here. 4 into 9 goes twice with 1 left over. 4 into 16 is 4. So our answer is x equals 24. All right, you should always check your work, especially you should check for extraneous solutions. So let's check our solution, x equals 24. We're going to check it by plugging it back in to our original equation. So I have log base 4 of 100 minus log base 4 of 24 plus 1. That's squishing it in. Hold on. Is equal to 1. Sorry, this is a 1 right here. 24 plus 1. Okay, let's simplify that. Log base 4 of 100 minus 24 plus 1 here is log base 4 of 25 equals to 1. Using the quotient property, I'm going to write log base 4 100 over 25, which equals to 1. course, I can reduce 100 over 25, which is just log base 4. 100 over 25 is just 4, which equals to 1. Is it true that log base 4 is 1? If I switch forms, I could say 4 to the 1 is equal to 4. That's true. So therefore, our answer, x equals 24, works out.